Hello everyone, I welcome you all in this session for the discussion of paper number 2 of JEE Advanced 2021. In this session, I will be solving the questions right in front of you. Official paper has been released and we will be discussing the paper and I will be solving the questions right in front of you. Questions of physical and inorganic chemistry I will be discussing in this session. Questions of organic chemistry will be discussed in the another session. So, paper 2, question number 1, this is from organic chemistry side. Will be discussed in the another session. Second question is also from organic chemistry. Next question, question number 3. This is from physical chemistry, chemical kinetics. It's a good question. For the following reaction, 2x plus y giving us P, the product. The rate of reaction is equal to dP by dt is K into x. 2 moles of x are mixed with 1 mole of y to make 1 liter of the solution, and at 50 seconds, 0.5 mole of y is left in the container. So, initially we have been given that we have taken 2 moles of x and 1 mole of y, and at t equal to 50 seconds, 0.5 mole of y is remaining. So, 1 mole of x will remain, and according to the stoichiometry, 0.5 mole of p will get formed. And according to the rate law, we know that minus half of dx by dt should be equal to minus dy upon dt should be dp by dt, and that is equal to k into x. This is the rate law. Now, dp by dt is equal to k into x, so I have written it correctly. Now, for dx by dt, 2 moles of x are mixed, and now it is given that 50 seconds 0.5 mole of y is left in the reaction mixture. The correct statement about the reaction is the rate constant k of the reaction. Now, from this we can make the differential equation minus dx by dt is equal to 2k into concentration of x. Now, this 2k will act as rate constant for x. So, we can write 2k to be, let us say, kx into x raised to power 1. Now, if we solve this differential equation for x, then we will be getting that x is equal to initial x concentration into e raised to power minus kx into t. Now, it is given to us that at t equal to 50 second, 1 mole of x will be reacting, 50% of x will be reacting. So, half life for x is going to be 50 second. So, half life of x is equal to 50 second is going to be correct, and with the help of this half life we can calculate the value of kx. So, this kx we know that it is going to be ln 2 upon t half, that is 50. So, kx which is equal to 2k, that is equal to ln 2 by 50. So, the value of k is coming out to be ln 2 by 100. So, k, that rate constant of the reaction is 0.693 upon 100. So, option A, rate constant of the reaction is 13.86 in 10 to the power minus 4. That is coming out to be incorrect because k is 6.93 into 10 to the power minus 3. So, A is incorrect option, B is correct. At 50 second, minus dx by dt is equal to this. So, now if we want to calculate minus dx by dt, then that is equal to kx into concentration of x. So, kx is equal to 2k. So, value of kx we can write, that is 2k into concentration of x at t equal to 50 second, and that is equal to 1. So, that way we can calculate the value of dx by dt, which will come out to be, let us say if I calculate this c part, then minus dx by dt will be equal to kx, that is 2 into 6.93 into 10 to the power minus 3 into concentration of x, that is equal to 1. So, this is correct option. C is going to be correct option for the question. Similarly, at 100 second, if we want to calculate d by dt at 100 second. Now, this is at t equal to 50, at 100 again half of the reactants will react. So, x will become half. So, if we want to calculate at 100 second the value of minus dy by dt, so minus dy by dt is equal to k into x. We have to substitute the value of k and the value of x. So, this k is 6.93 into 10 to the power minus 3, and the value of x will be equal to half. So, it is equal to 3.46 into 10 to the power minus 3. This is correct. So, B, C, D are going to be correct options for this question. It is a good question involving the calculations also, and the understanding of this rate law is very much required. Rate constant of the reaction, that is K, that rate constant of reaction K is going to be rate constant for P, that is also going to be rate constant for Y, but K is not going to be rate constant for X. Rate constant for X, dx by dt is equal to minus 2K into x raised to power 1. So, rate constant for the reaction of X is going to be 2K. So, there can be some doubt, or let us say some of the students may solve it incorrectly. They can take rate constant of X to be equal to K, which is not correct. So, this way it is a tough question from chemical kinetics. I think the calculations are clear. Next is in paper 2, this is from coordination chemistry, coordination compounds. The pair of the complexes both exhibit tetrahedral geometry. Tetrahedral geometry is that when there is going to be weak field ligand, then there will be chances of formation of tetrahedral complex, or if there is D8 configuration, then there will be chances of tetrahedral complex formation. FeCl4 minus, so this is a weak field ligand, so it should be tetrahedral. FeCO whole 4 with 2 minus, Fe, that is 3d6 4s2 configuration 2 minus, so that way it is 3d8 and 4s2, this is 3d10, so this is d10 configuration. CO is a strong field ligand, but this is d10 configuration. So, that way this is going to be tetrahedral. So, both are tetrahedral. This is also going to be d10 configuration, it has to be tetrahedral, this is a weak field ligand, so both will be tetrahedral. This is tetrahedral, but this complex is dsp2 hybridized square planar. So, C will not be the correct answer, and this is going to be d10 configuration, that is also d10 configuration. So, this both the complexes are going to be tetrahedral. So, A, B, D, either weak field ligands with coordination number equal to 4 or d10 configurations will lead to tetrahedral complex formation. So, it is a moderate level question from coordination chemistry. Next question is from nitrogen family, nitrogen and phosphorus family. Correct statement related to oxo acids of phosphorus. Upon heating, phosphorus acid undergoes disproportionation to phosphoric acid and phosphine, correct, this we know. This undergoes disproportionation to produce phosphine and phosphoric acid. Phosphorus can act as reducing agent, correct, phosphoric acid cannot. This is plus 3 oxidation number of phosphorus plus 5 oxidation number of phosphorus, that is maximum oxidation number allowed. Phosphorus is a monobasic, this is incorrect, it is not monobasic, it is dibasic. So, that way this is incorrect statement. H atom of pH bond in phosphorus is not ionizable in water, that is correct. This is not acidic hydrogen, pH bond. We know the structure of phosphorus acid, this is P double bond O, there is one pH bond and there are two POH bonds. So, two ionizable hydrogens are there, it is a dibasic acid. So, it is a simple question from nitrogen family about oxy acid of phosphorus. Next question is again of the same pattern, question STEM is given, and based on this information two questions are there, question number 7 and 8. This is question from electrochemistry, electrolytic conductance. Limiting molar conductivity of weak monobasic acid is given to us. So, lambda m naught of the monobasic acid is given to us. At 298 Kelvin for aqueous solution of the acid, which is having some concentration, the degree of dissociation is alpha. So, the molar conductivity is Y, and one question is calculation of alpha only. So, we already know that alpha is equal to lambda m at concentration C upon lambda m at 0 concentration. So, we can substitute the data, this is Y into 10 raised to power 2 upon 4 into 10 raised to power 2, that is Y upon 4 is the value of alpha. So, this is one equation. Next is at 298 Kelvin upon 20 times dilution. So, we have changed the concentration now, it is not going to be C, it is going to be C dash. The molar conductivity of the solution becomes 3 times. So, the number of ions must become 3 times, the degree of dissociation should become 3 times, then only this is possible. And now we want to calculate the value of Y. So, now alpha dash at newer concentration, at new concentration is going to be 3 times alpha. But writing the same relation won't help us. So, we have to use that K of the monobasic acid is going to remain same. So, Ka is equal to C alpha square upon 1 minus alpha, and this is also equal to C upon 20 into 3 alpha ka whole square upon 1 minus 3 alpha. K of the acid will be same. Once the concentration is C, degree of dissociation is alpha. When concentration has become C by 20, degree of dissociation is 3 times. This is what is given in the question. So, by solving this equation, we will be getting the value of alpha. So, if you solve this equation, the alpha comes out to be approximately 0.22. I already have solved this question in memory based solution, which we already have prepared and which we have shared to you. We reproduce this question on the basis of, let us say, discussion with the students. So, the same data was there, alpha is equal to 0.22, and substituting the value of alpha will give us the value of Y, that is equal to 0.88. So, this answer is 0.22, this answer is 0.88, value of alpha and Y. But this is a very good question from electrochemistry. It is not a simple question, it is moderate to tough question from electrochemistry. A good question. Next is another question time. This is from redox reactions, and it is also involving reaction of organic chemistry, in which nitrobenzene is being reduced into this organic salt. After reduction, organic salt will get produced, that is aniline will be produced. So, first SN is reacting with HCl quantitatively to produce the salt. So, first reaction is going to be SN will be reacting with HCl to produce SnCl2 and H2. Entire amount of the salt reacted with Y gram of nitrobenzene. Now, this is reacting with Y gram of nitrobenzene. This is reacting with SnCl2 in presence of HCl, and this will give us aniline. In presence of HCl, this is going to be ultimately anilinium chloride, and SnCl2 will get oxidized into SnCl4. By redox, we can easily calculate that in this case there will be involvement of 6 electrons. So, SnCl2 getting converted into SnCl4, that will be involving only 2 electrons. So, stoichiometrically 1 mole of nitrobenzene will require 3 moles of SnCl2. This is the catch. If we know this, then we can easily solve the equation. Now, it is given to us that 1.29 gram of the organic salt is anilinium chloride. Data is simple, that because the molar mass of anilinium chloride is going to be 129 gram. So, now we know that how many moles of this are getting produced, 0.01 mole. So, 0.01 mole anilinium chloride will be produced from how many moles of nitrobenzene, 0.01 mole only. So, Y gram of nitrobenzene means 0.01 mole of nitrobenzene. We can convert this into mass of nitrobenzene, Y gram. 0.01 into 123 is the molar mass of nitrobenzene. So, Y is going to be 1.23 gram. Calculation of Y is easy. Now, X is mass of Sn. So, moles of SnCl2 required for this reaction will be 0.03 according to mole concept. So, now we want to calculate mass of 0.03 moles of Sn, tin, and the molar mass of Sn is given to us, that is 119. So, X what is the value of x? X is going to be 0.03 into 119. That's the value of x. So it's a question from redox reactions, and reaction from organic chemistry is also involved. So that way it's a mixed question. It's a good question then, because of the mixture especially. Next question is again from redox reactions only. A sample 5.6 gram total weight containing iron. So this is containing some iron and some impurity can be there. Is completely dissolved in cold dilute HCl. Iron with HCl will produce FeCl2, ferrous. To prepare 250 ml of the solution. Now titration of 25 ml of this solution required 12.5 of 0.03 molar KMnO4. KMnO4 will oxidize ferrous to ferric. So now if out of 5.6 x gram, x is they already have used x, so we want to calculate x and y. So y percent is y weight. Okay, so let me assume that a gram iron is present. How many moles of iron? A upon 56. How many moles of ferrous will be produced? A upon 56 only. These many moles will be present in 250 ml solution. 250 ml will be containing these many moles. 25 ml of this, so number of moles will be equal to this. 25 ml is 1/10. Number of moles of ferrous will be this. Number of millimoles will be 1000 times. Number of millimoles of ferrous will be number of milliequivalents, because valency factor of iron is going to be 1. Number of milliequivalents of ferrous will be equal to number of milliequivalents of KMnO4. So this is 12.5 into 0.03 into valency factor 5. So this is going to give us the value of A. A we can calculate. A is going to be mass of iron, and that is going to give us the percentage. So y, the calculation of y we can do from here. And the number of moles of ferrous present in 250 ml of the solution. So 250 ml is going to contain this much number of moles, A upon 56. So A is going to give us everything. So this is the only equation which we have to solve to get the answer. So A upon 56 into 100 is equal to, this is this much. So this is how much? 12.5 into 0.15. So if 15 is multiplied, this is going to be 5, this is 7, and this is 15 into 18. So this is going to be how much? 1.875. A upon 56 into 100. So we can calculate the value of A, and that is going to give us the amount of iron. So I think I have done the calculations correctly. Sample 5.6 gram. If A grams of iron are there, then A upon A grams of iron, then A upon 56 moles of iron in 250 ml. So 25 is 1/10 of this into 1000 is going to be number of millimoles. Number of millimoles of iron is number of milliequivalents. That should be milliequivalents of KMnO4. So KMnO4, number of milliequivalents we have done. Number of millimoles of moles of iron present in 250 ml. So that should be this multiplied by 10. Number of millimoles of iron should be equal to 12.5 into 0.03 into 5 into 10 times, because we want to calculate iron in 250 ml. So that is going to give us the value of x. So x and y we can calculate. So this is 12.5 into 0.03 number of millimoles into 5 is number of milliequivalents. Okay, I think we can do the calculation for x and y. So this is a question from titration, KMnO4 titration, redox reactions. The concept is clear. Next is question from organic chemistry. We will be discussing in another session. Then another question from organic chemistry. Next is precipitate X. I think we have a different slide for this. Brown ring is formed due to formation of, okay, a slide is missing in it. Okay, there was this question, precipitate X. The question, we want to identify the precipitate X. It was given in the question in the stem that when ferrous sulfate is reacting with potassium ferrocyanide, then what is going to be the precipitate formed. It is given in the stem, question stem, that white PPT is going to get formed when ferrous is reacting with ferrocyanide. When ferrous reacts with ferricyanide, then there is formation of Turnbull's blue, but when ferrous reacts with ferrocyanide, then white PPT K2Fe FeCN whole 6, this gets formed. This is white PPT. So, we have to identify this. So, white PPT is this, which if capped in air for longer time, then it will get converted into bluish in color because of the oxidation of iron, ferrous to ferric. Next question in the same question stem was, if ferrous sulfate is reacted with nitrate, ferrous ion if is reacted with nitrate in acidic medium, sulfuric acid, in presence of sulfuric acid, then we all know this is ring test for the nitrate, brown ring test. So, there will be complex formation, brown ring complex will get formed, and the formula for that is FeNO plus, and this is H2O whole 5 SO2. So, next question was this only, that what is the formula for this brown ring complex, formula for brown ring complex, and that is this: iron is present in +1 oxidation number, NO is present in +1 oxidation number. This is a very important complex. We all study this in very detail in coordination chemistry. So, both these complexes, complex of ferrous with ferrocyanide and brown ring complex, are important complexes. So, these were two questions from inorganic chemistry. Next question from physical chemistry: 1 mole of ideal gas at 900 Kelvin undergoes two reversible processes. First is going to be adiabatic because entropy is remaining constant. Second is going to be isothermal because internal energy is remaining constant. So, adiabatic, then isothermal, followed by this as shown below. If the work done by gas in two processes are equal, so we should be calculating work done in process number 1. In process number 1, being adiabatic, work done should be equal to delta U because the process is adiabatic. According to first law, this delta U is equal to Q plus W, Q is 0. So, this is, so we can calculate delta U during this first process, that delta U will be equal to minus 1800 R. So, that should be the work done, W1 minus 1800 R, 2250 minus 450, that is 1800. Now, this is also equal to work done in the second process. Second being isothermal, work done is minus nRT, ln of V final upon V initial. So, this is what we want to calculate. So, we can easily see that ln of V3 by V2 is equal to, this R will be cancelled. So, this is 1800 upon NT, and is already given to us 1 mole. So, this is 1800 upon T. So, we want to calculate temperature. What is going to be temperature for this isothermal expansion? Now, temperature can be calculated by this value of U upon R. U is equal to 450 R. Now, U is equal to 5 by 2 R into T, because CV of the gas is given to us 5 by 2 R, n is equal to 1. So, from this we can calculate T is equal to 180 Kelvin. So, if T is equal to 180 Kelvin and this is 1800, so this way this is going to be 10. So, correct answer for this question should be 10. It is a question from thermodynamics, moderate level question. We can do the calculations in this way. After question number 17, next question is question number 18. Consider a helium atom that absorbs a photon of wavelength this much. The change in velocity of the helium atom after the photon absorption. Assume momentum conservation when photon is absorbed. So, momentum of the photon will be given to momentum to helium. So, m into delta V should be h upon lambda. Momentum of photon is equal to momentum change in the momentum of helium. So, m mass of helium atom, that is equal to 4 gram, that is 4 into 10 power minus 3 kilogram upon Avogadro number. This is mass per atom in SI units, into delta V is equal to h, that is 6.6 into 10 power minus 34 upon 330 into 10 power minus 9. All units are, all the quantities are in SI units. So, if we make it 3.3, then this will be into 10 to the power minus 2 further, 10 to the power plus 2, sorry. Now, this is equal to 2, this is 2 and 3, so this 2 we can cancel. So, delta V is coming out to be 3 into 10 raised to the power minus 34 plus 7 plus 23 plus 3. I think I have written all the quantities correctly. So, this is coming out to be 0.3 meter per second. Now, if we want to do the calculation in centimeter per second, then we have to multiply it with 100. So, correct answer to this question should be 30 centimeter per second. This was question number 18, simple momentum conservation. It can be a question from physics also. And last question of chemistry, ozonolysis of ClO2 produces an oxide of chlorine. Average oxidation number of chlorine in this oxide. Ozone is going to oxidize ClO2. This reaction is ClO2 will get oxidized with ozone, and this produces actually Cl2O6 and oxygen will be produced. Cl2O6, the oxidation number of chlorine is going to be plus 6. So, average oxidation number is going to be plus 6 only. It is a reaction from halogen family. That is all. These are all the questions from physical and inorganic chemistry of paper 2. I have solved all the questions. I have done maximum of the calculations. So, this way all the students can understand that the questions, many of the data were of let us say were not of on let us say complicated side. Many of the data were given to us so that the calculations can be made simple, and I have calculated almost every question to the end. So, this is the initial video solutions which we have provided, initial discussion. We will be further improving the quality of the presentation. So, you can let us say refer to those videos for better quality, and these videos are we have prepared these videos directly after getting the official paper, and we almost are solving the questions directly from the paper only. So, there can be some calculation mistakes, but I think the concepts are very clear to us, and many of the calculations I have done correctly also. So, this is all for this particular session. Thank you.